Good day everyone. We are here to present our group project in operating system concept which is multi-level queue feedback. The group's main objectives are to develop round robin and our team J decided to choose MLFQ scheduling algorithm, hence these are the objectives of our group. To display the number of time quantum of the user wants to input. Next is to display the total arrival time and burst time. Next is to manipulate the computation of each processes and print the completion of each process through Gantt chart using a programming language. Next is to give benefit for the professor and students so they can use the program in their educational purposes.
So next is the scope and delimitation. So for the execution of program entered by the user, the execution is limited in the program. So next, so the process is between the minimum of 3 processes and maximum of 10 processes. So next is for the burst time. So the burst time is the minimum process will be 1 and the maximum is 15. And for the arrival time, the minimum process will be 0 and the maximum is 10. For the quantum time, the minimum process will be 3 and the maximum is 15. On the other hand, the completion time, turnaround time, and waiting time will be computed based on the input used. So this program reprints the Gantt chart accordingly of what users inputted, and for the table chart, it will show all the process correspondingly.
And for our demo, we prepare one set of data. The given data has 6 processes with the quantum time 1 of 3 milliseconds and quantum time 2 with 4 milliseconds. The process 1 arrival time was 0 and the burst time of process 1 is 3. Process 2 has arrival time of 4 and burst time of 1. Process 3 has arrival of 5 and burst time of 4. Process 4 has arrival of 6 and burst time of 8. And process 5 has arrival time of 6, burst time of 3. And process 6 has arrival of 8 with a burst time of 8. So here I enter all the number of processes that we have is 6. Um, the processes with its arrival time and burst time. And here is the quantum time 1 and 2. Then it will you will see here the Gantt chart, overall Gantt chart for the 3Q, which is the round robin with quantum time of 3 milliseconds and round robin with quantum time of 4 milliseconds, and the Q3, which is first come first serve. So now we will try to solve it. So here the first process that has arrived was the process 1. With the burst time of 3. So the quantum time for Q1 is 3. So all the burst time of process 1 will be processed. So The remaining time for process 1 was 0. The next process that has arrived in time 3 was none, so it will be idle because the second process will arrive at 4, and that will be process 2 at 4. Burst time of process 2 was 1. So process for all the burst time for process 2 was complete. So there's no remaining time. And the next process that will arrive was process 3 at time 5. Has a burst time of 4 milliseconds. So we have a quantum time that is 3 milliseconds. So we only execute 3 milliseconds. So here you will see the processes that has a remaining time. So now we will process the um, those those processes in Q2. So the first one is P3. So P4 and P6 to be processed at the third queue, which is FCFS, or first come first serve. So the first one is P4. So now that we finish our gun for per queue, we will now proceed to overall Gantt chart. So as you can see, if we will compare the two Gantt chart, you will see here they have the same. You will see here that they are the same. So here, the P1 will process at 0 to 3, and there will be idle, which is no processes. And at P4, P2 will process at 4 to 5, and P3 process at 5 to 8. P4 process at 8 to 11. P5 process at 11 to 14. P6 will be processed at 4 to 17, and so on and so forth. So now we will compute for chart their completion time. So now that we had the completion time of all processes, we will compute for turnaround time and waiting time. So for turnaround time, it's completion time minus the arrival time. For waiting time, it's turnaround time minus the burst time. And we will get the summation total of turnaround time. And here you will see the average for turnaround time and average for waiting time. So now we will compare it to our program, our output. P1 has a completion time of 3, P2 is 5, P3 is 18, 4 is 27, P5 is 14, and P6 is 28. So now their turnaround time is 3, 1, 13, 21, 8, and 20. And a total turnaround time of 66, which as you can see here at the table. So the average for waiting time is 6.50 milliseconds and the average for turnaround time is 11 milliseconds. So this shows that the output for our program is the same as the one that we computed.
So this is the end of our presentation. I'm Maria Teres Satsat.
I'm John Elmar D. Rodrigo.
I'm Monica F. Ordonez and we are Team J. Thank you for listening to us.